There we go. All set. Okay. So I was saying we got a great group. Really grateful to have three awesome presentations lined up today from industry leaders building a reuse ecosystem in the built environment, and particularly in the Bay Area. So just as a primer here, CLF LA. If you want to do next slide, we're just going to start in case anyone's unfamiliar, but we're here to talk about embodied carbon. If you don't want to hear about that, then you found yourself in the wrong webinar. But we talk about this because buildings have a really tremendous impact on our environment. We know that buildings contribute 40% of global greenhouse gas emissions, and new buildings, the materials and embodied carbon for that are expected to contribute half of emissions between now and 2050. So a lot to do with our climate change problem. There's a lot more information on this and a more comprehensive embodied carbon 101 on the CLF website, and happy to share that if anyone is new to the topic. And today we have a really interesting aspect, one aspect of embodied carbon, which is talking about waste in the built environment. And so I heard something recently that said it characterized waste is a label for things that we don't know what to do with. Once we have a purpose for it, it's no longer considered waste. And it's through this lens that we're going to talk about embodied carbon today. Our first speaker is going to be Marcus Hopper. He's an influential figure as his role in the Northwest Regional Design Management Leader at Gensler in San Francisco. In 2018, he was part of a research team that aimed to bring awareness to the circular economy and identify how the industry can bolster a reuse process within design work. Findings were published in the Gensler Research Institute white paper, What is Old is New Again, Circumnavigating the Circular Economy. And he's also a prominent member of the All for Reuse group. Then we got Daniel Kietzer, who is ecosystem growth leader at Rheaply. He's based in Austin, joining us today from DC, actually. He has over 10 years of experience in both the for-profit and nonprofit sectors, designing and leading impact-focused circular economy and sustainability programs. At Rheaply, he's working to scale their online material marketplace around the country, including Texas, Tennessee, Michigan, Ohio, Washington, and soon to launch. I think they're in still beta phases in San Francisco and the Bay Area, which is really exciting. Rheaply is also partnered with numerous local municipalities and also clearly doing stuff at the federal level in DC, all around circular economy principles in the built environment. And then our last presentation, I think people really get a kick out of is Eric Law and Jorie Wisnefski, and they're with Urban Machine, a startup salvaging timber products with a pretty awesome, you'll see a video, machine that uses AI and computer vision, and it salvages wood waste to be reused. So as we get into the presentations here, I'm about to hand it off, but we request that everyone just turn their camera off and mute. And you can drop questions in the chat as we go, but we'll just do all the presentations and then have Q&A and discussion at the end. So with that, I'm going to hand it off to Marcus and get the ball rolling.
Yeah. Okay, everyone close their eyes while I get my screen shared. Let's see here. Oh, hey, Luke, I think you have to stop sharing for me to share. Okay, there we go. Thank you. All right, a few more minutes. Okay, is everybody seeing the Luke, are you seeing the like presentation screen?
We just see the PowerPoint. Looks good.
Perfect. Okay, great. All right. Hi, everybody. Thank you for
I think you need to
inviting me
do
here.
full screen, by the way.
Oh,
Yeah.
you're not seeing it?
We see
So we're seeing a PowerPoint
full
window, not the full
PowerPoint.
screen.
Okay. Okay, this should work. Do you see it now?
Yep, perfect.
Okay, perfect. Great, got it to work. All right. Well, thank you everybody for having me join this webinar. I'm really, really honored to be here with Daniel, Luke, and Jorie. I'm going to set the stage. And so what I'll go through is just really high level. It's not going to get into the specifics because I think this group is well educated around embodied carbon. But I'm going to set the stage specifically around material reuse. And then some of the things that we've been doing here with others in the Bay Area. So I'll just start. Just waiting for this delay. Try to switch the screen. Let's see if I can do this way. Okay. So I think the first thing where I want to start is really with a quote from one of my colleagues, partners from All for Reuse. And if you don't know about allforreuse.org, just look us up. We're really just a bunch of design professionals, construction folks, looking at how to kind of change how building material reuse is looked at. And so one of the quotes that Andrew Ellsworth from Doors Unhinged made in that article, I think last year, was this really interesting kind of like where, building material reuse is kind of where carbon and waste meet, right? It's this kind of really interesting intersection. And as we start to think about that, and specifically with Andrew and his business, right, he's kind of developed a business around reuse of commercial doors. We know that there's a supply of materials out there. They're coming out of projects all the time. It's really, I think the challenge for this group and our community is really thinking about how to foster the demand, right? How do we start to kind of build systems that help enhance and foster the demand side of the supply chain? So when we started, this is probably about 2 years old, we kind of just laid out like a journey map. Like if you're thinking about reuse for a project, and this is specifically for more of an interior side project, like a commercial interiors project, like how would we map it out, right? How would you sit down as a team and kind of think about this? So, if you think about it like a journey or a game, it's really, there's some things that you need to consider. So everything kind of to the left side is really just things to consider. It's schedule, budget, anything that you would typically have on a project. But there may be some specific questions to ask, right? What's the client's appetite for this? What's kind of the best case scenario if we were to go forward? Every project really needs to start with a plan, right? We do that already, but we really need to kind of start with a strategy, like a reuse strategy for every project. There's going to be a point when the project gets going, which I think is the most exciting piece, is really kind of this area of discovery, right? There's going to be things that you see. Thinking about projects in reverse, right? You're not looking at designing a project, having a concept, and then finding the materials. It may be the other way around, where you have materials, and then you work around those materials to design the project. The partnerships are going to be super important. We'll get into that a little bit, but the partnerships are going to be people that you work with, right? So, these are the ones that are going to help you implement the project successfully. They're going to have knowledge that you may not have. So it's a lot of learning through meeting people. During the design process, and don't try to read all of this, like specifically, I'll send this to everybody after the call, but there are things to consider, right? You're going to have to really incorporate like flexibility in the process. There'll be a lot of twists and turns that you're just going to have to kind of navigate. And then you're going to have to, again, take the whole project team with you, right? Contractor, the client, other designers or architects that may be working with you, your engineering team. As you're starting to like develop the design, you need to think about the next team. Somebody is going to use these materials again. And so where we start to look at perform and deliver, it's really about designing these things so they can be disassembled later. Like, can you find a way of attachment other than glue? How can we reuse these materials so they have a longer life and they can be reused by others? Kind of at the end of the process is really just the communication piece. Like, communicating to other teams like where you've succeeded, things that you may have done differently, letting people know that. And the documentation piece, which is the kind of the data behind it, right? What did you save? How much of it? All of that is going to be important as you start going repeat all the way back to start and doing it again. So again, this is more of a sharing model. It's very much open source, where we're going to have to work together to kind of figure out this like complex system that doesn't exist. With material reuse, it's really all about time. It comes down to, if you had all the time in the world, that'd be great, but time is really kind of not going to be your friend. And so the sooner that you start, the better opportunities you'll have in success. So every project should really start with a reuse strategy. And a reuse strategy is really at the real estate level. It's not at the design and construction level. So this is really working with PMs, the client side, to kind of incorporate some of these processes in the overall project, right? It's included in the budget. So there's no surprises later on when, oh, we never costed that. We can't afford that. Our budget will not allow that to happen. You've already kind of implemented that into the process of the overall project. The reuse strategy may also have an auditing piece as well. So as you're looking at buildings and you're looking at materials, there may be some auditing that may take place. So you kind of understand what you have currently on site, so that when we're ready to start the project, we're already working way ahead of the curve, right? We're like ahead of like where we would typically start. The partnerships are important. So like the 3 to 6 month range is really when we really need to start to kind of engaging the partners. So the auditing piece I've mentioned, like a salvaging partner, having them come in and audit the materials. This again saves us time when we're really starting the project traditionally. The 1 to 4 week time frame is really this kind of hotline. During those twists and turns during the process, you're going to have your hotline of folks that you're going to call. It's not always going to be perfect. Even the most perfect reuse strategy, blueprint, plan may have some holes. And so that network that you'll start to develop as you start to develop your partnership list will be essential as you start to kind of navigate and move through the process. When we have, working together in the Bay Area, we've developed an alliance, the All for Reuse Alliance. And so this has been, again, a group of folks that are really coming to the table from all different types of perspectives. We have folks from the Department of the Environment that are speaking of it from a policy side from San Francisco. We have folks that are like myself in the design industry. We have folks that are coming from construction, people that are coming from the public sector. And so it's been a really interesting conversation about how each of these pieces play a part in this overall ecosystem. So really kind of 3 things that the group is looking at. It's environmental impact, like where can we reduce, right? Carbon, waste. We're looking at the kind of the enterprises piece, right? The workforce, like can this generate jobs? Where can it generate jobs? And then we're also looking at scaling it up, right? When people think about material reuse, maybe in the past, it's more, hey, we're going to put some reclaimed wood on a wall. That's great. It's going to be more of a finished material. We're looking at scaling it up to the point where it just becomes a normal thing that we use in our projects. Talking with the city of San Francisco, the Department of the Environment, they've also been looking at this from a policy side. And so there's this kind of interesting, again, intersection similar to what Andrew had talked about, right, in his quote, between waste and green building, right? There's this kind of intersection, and that's where kind of carbon meets in the middle. So they started kind of looking at this as a city, right, as their Department of the Environment, because they are looking at developing policy, right? Policy is going to be key in moving some of this forward, creating those incentives. So they started to look at the system, right? Where can we start to kind of intervene in the typical traditional system? So what we're showing here, this comes to the Department of the Environment, the typical like process, right? The extraction, manufacturing, it goes into design, we're specifying, it goes into construction, into live disposal. And so they started to kind of spider web it, right? It's like kind of like the crazy person with like the pins on the wall and the yarn, and they're kind of connecting all the pieces. And so they started to look at areas in this kind of workflow where they could kind of intervene, like where could we start to kind of pull apart and stick in things that can help with this material reuse idea. So what we were asked to do early last year, Gensler, we were joined by the Reuse People, which is a local nonprofit. Madrone is a demolition contractor focusing on sustainable demolition, and Stop Waste. We were asked to kind of really focus on this like recovery resale piece Like, let's just look at the materials that are coming out. How can we kind of start to create the demand there? The city needs this for policy, right? As they develop policy, they have to kind of complete the whole picture, right? Before you put policy out in the world, you have to have like a somewhat operating system for it to be successful. And so they're looking at developing this network for suppliers and receivers, so making that public to the folks that are using the within the kind of jurisdiction. The virtual asset management piece, which Daniel will talk about in a minute, and then this physical laydown space, like, where do the materials go? They can't always be just in time, stored on site. When purchased, they may have to go somewhere, like in escrow. Like, where do they go? The virtual exchange is very important, and I won't get into too much depth because Daniel's here to talk about this, but this is really kind of, and it's like the first step. It's like just creating visibility, like just showing people what's out there. What are all the materials that are currently existing out there, making it visible. The next piece is really, and this is where our team dove into. This is like a 8-week study. It was really, really fast. Really looking at this, the actual storage of it, right? The materials, and where are they going to go? Like, how would this work? And so this tied into a larger concept that the city was talking about and working on called the Building Resources Innovation Center, or BRIC. And so the vision of it is really simple. It's like really looking at this kind of flexible system, a system that can be relocated, a system that can be replicated, that can really enhance the building material reuse within the commercial construction market. And so the concept is really 3 parts, right? We're really looking at trying to streamline the process, right? Where do these, kind of help, push it forward? Looking at how these sites or this system could really benefit the local community. Building material reuse is really local, and so there could be opportunities to help local communities. This system, because specifically in San Francisco or anywhere in California, real estate's expensive. And so how do you design this system so that it can be, again, relocatable, right? Can it be designed around disassembly? It's there today, can be picked up and moved somewhere else. And then really celebrating this as a place for the aggregator, right? These materials are coming in. It needs to be a really clean system on how to kind of parse out the materials. They're going in for resale, possibly donation, possibly takeout program. So this is kind of the overview of the concept. It's based on a kind of parts, right? So the system would have like 3 main parts. Site operations, which is kind of the heart of each site. Material storage, which is designed on a module, right? So a module of a pallet and the clearances for a forklift. It would be weather protected. And then the community facing piece, right? Which is essentially the kind of thing that makes each site very specific, right? Because there are going to be various sites throughout, specific like locality. So if we dive into the first part, which is site operations, like this is kind of the mission control, right? This is like the home base. This is where stuff gets done. It has to be super functional, right? This is where the site operator, who is really running a business, right, will kind of oversee this specific site. We talked about the aggregators. So it has to be super, going back to functionality, it's a site that has enough layout space so when things are coming in, there's space for them to start to like move the materials around. It's again, either going back to a take back program area to go back to a manufacturer, moving to the retail side of the site, or going to a donation stream. The concept around material storage is interesting because every site would be slightly different, right? They're not all going to be the same site or size or shape. So really looking at this from a by material. So when we studied this last year, we looked at materials that were coming out of commercial interior projects in the past like 10 years. We went 10 years back. And so these materials that are listed here, starting with carpet, going all the way to ceiling tile, these are like the top 9 materials that were coming out of projects. And so we've kind of created, our team created like almost a value matrix, looking at it through different lenses, economic, social, and environmental. So we can take a closer look at those first 3. And I can dive into it a little deeper. And so as we look at the sites and say you're a site operator, you're looking at, okay, what's the ROI on the site? How is it going to pay off? And you have a specific size of site, you're going to need to look at the materials from these 3 lenses. on the economic side, if we say take carpet tile, for instance, which is the first one, 3,000 carpet tiles, they stack, they're easily storable in a smaller square footage of area. From an economic standpoint, they could bring in 3,000 carpet tiles, could roughly bring in about $1,500. You have some labor hours associated with that. So there's a lot of pieces and parts. So there's going to be more labor hours generated from that, which would be great. You're going to create more workable hours for people for employment. And then in terms of the environmental piece, and this was all calculated by Ted Reef at the Reuse people, in terms of embodied energy, you're getting almost 16,000 megajoule. And that's great. So you can look at carpet tile. That's how much I'm going to get in terms of a retail side. I have a good number in terms of workable hours that I can employ somebody, and then I have a good kind of environmental impact. If we move down the notch to doors are, you're going to get less on a pallet, right? About 20 doors. In terms of the value, about $40 a door, right, for reuse. The workable hours in terms of folks on site, this doesn't incorporate the deconstruction piece from the site they're coming from. It's really just the number of hours on site. It's a lot less. The environmental impact, though, is much higher, right? So you're going to get a lot more in terms of embodied energy for the doors, but not so much retail value. The kitchen cabinets, millwork, they're somewhere in the middle, right? They're boxier, right? You get a good price. They're slightly boxier, so the number of hours associated with somebody moving them around, maybe a little bit more, but not as much as like carpet tile. And then the environmental impact is slightly less than the carpet tile. So again, as a site operator, you can kind of make a determination what's going to give you what going to achieve your goals, right? From a retail cost standpoint, from the type of number of jobs that you're trying to generate, and then also from the environmental impact. The last piece was that community-facing piece, right? This is really important because every site being different, this is really how each site kind of shows its individual flavor. It's going to be the front door of every site. This takes it beyond kind of a material transfer station. This really becomes like the social side of materials. And so, working with like local agencies here, we were talking to the Workforce Development Agency. We were talking to folks that were living in kind of the art activation piece of it. Local design schools, California College of the Arts was involved. And so how do you start to create these sites as a place for people, not just materials? We were also talking to other nonprofits like the San Francisco Food Bank. They also have a need for collecting food and also distributing it to the local community. This could be a site where they could do that as well. So we feel that brick is really like an overall concept, not just building materials, and reuse can be kind of the a piece, but a catalyst to help like the communities that they serve. So the last piece is really the kind of size of the site. So our study was based on this 1.5 acre. It's like the kind of perfect size. It has a nice proportion of the three chunks, right? The community facing, the site operations, and the material storage. But some sites will be smaller. And so as you look at the smaller sites, you're just going to have to readjust. And that's where that matrix of the materials kind of comes into play. Like, what are you going to choose? In all of the scenarios, the one thing that will stay the same is the site ops, right? That will really never kind of, it's like kind of as economies of scale, it's never really going to change. But the material storage will change, and so will the kind of community facing piece. So that just gives you kind of a quick outline. There's so much more out there. So I'll put these links into the chat. The first one is about kind of the analysis, the more in-depth paper that the slides that I showed you kind of, it goes into like quantities and some of the calculations that we found, like how do we determine like some of those pallet sizes and numbers. The other piece is from the city of San Francisco, and a lot of the work they were doing, they did some extensive work on construction material surplus, like contractors are over ordering. Where does that go? Can we put it back into the market? And the last piece is just some links for the all for use site, some cool things that our team has been doing. I think the ecosystem map that Yarden Harari from CRTKL put together is amazing. I'll also send you a link of one of her recent videos that she put out earlier this year. So I'll probably put these links in the chat, and I'll hand it over to Daniel to kind of talk about some of the work that Rheaply's been doing.
Awesome. Thank you, Marcus.
Yeah.
Let's see, we'll do this. We'll do this. All right. Should be sharing the screen now. Yeah, wonderful background, Marcus. Fantastic job, as always. I love hearing you talk about this subject. So yeah, I'm Daniel. I'm with Rheaply.
Oh, Daniel, by the way, you're not full screen. Or if you,
This is about, I think this is as big as I can go, if that's okay.
that's fine. That's totally fine. Yeah.
Okay, cool. So yeah, I'm Daniel. I'm with Rheaply. We're here at Rheaply. We're on a mission to build a community where every workplace resource finds its next use. We do that through some software platforms and also some connected services as well. We've been at this since 2016. We get to work with some really cool companies and some really cool organizations along the way. And you can see a little more about our company's journey here down at the bottom. I'm going to talk today about one of our projects in the Bay Area, which is a circular marketplace for building products and materials. We've been at this project for a little while now, and we're just beginning to kind of quietly launch this to the public, which is super exciting. But the goal here, kind of following some threads that Marcus teed up so well, is really to build the digital infrastructure that is necessary to support the reuse of building materials and building products. So all of the great kind of physical components that Marcus was talking about around brick, this program here is designed to interlink with that project and other projects around the city and around the region to bring visibility to resources that aren't being used today and to connect those resources with new products or new projects that can put them back into a useful life. We're working with a whole lot of components of the built environment supply chain and built environment stakeholders, everyone from building owners to designers to large GCs to small GCs to small subs, and all of those great, very unique service providers that Marcus talked about, whether it's on the deconstruction side of things, folks that are adding value back into materials so they can be put back into useful life, a little bit of foreshadowing for our next speaker, or doing other things that are adding circularity back into the equation. So this project is launched and live today. We're starting to gather materials on the marketplace, which is super exciting, and beginning to kind of connect some of those threads to give those materials a next life. I don't have to tell this audience why this is so important, but just as a very high level overview and summary, these are some of those linkages between circularity and sustainability and carbon. We really want this to be a tool and a program that helps project managers reduce waste to landfill from project sites. We want to do that by connecting to demand organizations in the region. But more than that, we really believe that reuse can and should be the tip of the spear for climate action in the buildings industry. This is a relatively low-hanging fruit. We're not asking for a super resource intensive ask. We're just asking to take a better look at what's around us and to apply a little bit of creativity to thinking about how we can put those resources back into productive life. And in doing so, by sourcing better, by sourcing reused materials, by sourcing stuff that's already around us, reduce the amount of embodied carbon that we're bringing into new projects. These are some of the types of materials that we're really excited about when we talk about this project. The first being on the kind of front end of a building life cycle when new projects are going up, looking at surplus materials that often accumulate on site or are purchased as a part of of a building project. That can be attic stock material, that can be material that's rejected for aesthetic reasons, that can be install scrap, overestimates, just general surplus due to last minute changes. We know building projects are a very dynamic space and that happens a lot. We want to make sure all that good stuff is getting cataloged and captured and redirected to a new project. Marcus gave a quick shout out to the study that's on the right side. This was done by our partners at San Francisco Environment. It's a phenomenal study. And I can drop a link to it in the chat if you want to learn more. But there's a summary table kind of near the end that's shown here on the right side of the screen that speaks to some of the percentages that are typically seen on projects and some of the ways that these materials are being dealt with today. We want to improve that, streamline that, and build processes around getting that material back into new projects. Another kind of category of materials that we're really interested in kind of come at that tail end of a project. So when a building's being deconstructed or when a building's being renovated, we're also looking to kind of catalog and capture reclaimed materials from those projects. Those could be deconstructed building products and materials, cleanly source separated building materials, those unique statement pieces that folks like Marcus love to pull into projects and design around, materials that might maybe minimally processed, that are ready and accessible for new projects, or high volume building materials that are seeking new end markets. So things like gypsum, things like ceiling tiles that weren't deconstructed nicely, those sorts of products we also want to be taking a look at to see if there's a way of building some new systems that can put those materials back into new products. A couple of thoughts on how to get involved here. Obviously, if you have projects in the Bay Area, we would love to get those involved with us today. If you jump to rheaply.com/sign up, there's a quick form to get in touch with us. But I also wanted to use this time to make a little bit of an advanced announcement that this is coming to the Los Angeles area as well. And on that, on our website too, you can find ways of getting in touch with us, and we could put you in more of kind of like a wait list area, and we'd love to keep you in the loop as this starts to grow in the LA region too. We're super excited about this, and I know a lot of you all probably are as well. But just like in general, and Marcus touched on a lot of this in the reuse roadmap that he showed. It's really important to get out ahead of these things so we can plan and socialize way in advance before we're coming up against a week deadline to get materials offsite. The more lead time that we have understanding some of these things, the better. So it's always good to kind of plan and socialize this with peers, with colleagues, with people that are going to be managing materials. We would, of course, love any help spreading the word that we can. Events like this, networks like this are amazing, but definitely tell your peers in the industry about what we're working on too. This is my contact info. I'll drop it into the chat as well, and happy to get to some questions at the end of it all after our next presenters, which I'm super excited about. Thanks, y'all.
Thanks, Daniel. I think, Eric, you are up next. Eric and Jorie.
And Jorie.
Jorie, you're muted if you were talking.
Yep, I forgot about that. Thank you. Daniel, that's really exciting. I'm so glad that you were able to announce the LA today. That's awesome. Are you guys seeing my screen?
Now we see it.
Okay, great. There we go. All right, so I am Jorie Wisnefski. Good job to Luke saying my last name. It's not an easy one. I'm the marketing manager at Urban Machine. And for those of you who've been waiting, this is the robot portion of the, of course, my dog starts barking. I'm so sorry. Hang on. Oh my God, I'm so sorry. Anyway, Urban Machine is, for those of you who don't know, it's a robotics company. We are based in Oakland. We are reclaiming wood waste. And how it all got started, Eric Law, who's presenting with me today, he's our CEO. He was working, headed up an innovation and sustainability team at a major construction company. And in doing his research, he realized that 37 million tons of wood waste was going into the landfill every year, just in the United States alone. And he thought, there just has to be a better way to do this. So he reached out to someone he knew that he had done some robotics work with before, and asked if it was a possibility to automate the process, so that bringing reclaimed lumber was, a reality for the masses, not just, specialized labor. And Andrew is our CTO. So yes, obviously Andrew was able to automate that process. And to put it in perspective, that 37 million tons of wood waste, that's like 50% of what we log in the United States a year. So we need to be able to put that back into the build space. Especially since wood is the predominant construction material for residential. This is not letting me. There we go. Another challenge that we're facing is that in 60 years, these landfills, they're going to be full. And that old school way of just demolishing the building till the wood becomes like matchsticks, our landfills can't hold it. They're going to be at capacity. We all remember the lumber price volatility during COVID. It wasn't just toilet paper that had its 30 minutes of fame. Lumber also, people were buying it and hoarding it, and prices obviously took huge swings. We also have lumber shortages. This is all driving the prices of housing up as well. So just like we're all here for, I don't have to explain it to this group, but we are all here for to make things more circular. And what we're able to do is take that wood with our robot. We're able to take that wood from construction and demolition and put it back out there so that it gets another life. You think about it, the wood that has been standing in these buildings for 40 to 100 years, that grew in a real forest. So already it's hard. It's been, like I said, in the buildings for 40 to 100 years. So it's drying, it's straight, it's hard, it's beautiful, it's really tightly grained. And you can rip it, plane it, mill it, just like you would virgin lumber after it goes through our process to get rid of all of the metal. And then you're able to reuse it. Doesn't want to help me. There we go. One more. The environmental obligation is real. We all know that carbon is captured in wood. But what we have found in our research is that if we reclaim just half of that 37 million tons of wood waste, that's like the equivalent of taking 4 million cars off the road. We're really excited about that prospect. And, it takes 90% less energy to create our reclaimed lumber than it does to create virgin. So what you've all been waiting for is the machine itself. So this is our robot. It is 80 feet of, it's all built modularly, 80 feet of reclamation. The wood goes through these brushing station that removes contaminants. It also polishes the metal, so it makes it easier for the cameras to see it and the AI, to learn where it is. That flashing that you're seeing, that's the cameras looking for it, learning what kind of metal is in it. And those bird beak looking pickers are on all 4 sides of the wood at the same time, getting all the metal out of it. And it goes through a final metal detector to make sure that that wood is beautiful and ready to be reused in a project somewhere else, or right there on the same project, at the same place. And I'm going to let Eric take over from here.
Cool, thank you, Jorie.
Mhm.
Yeah, so as you guys saw, so this is our 3rd engineering prototype that we developed here in the shop. Our first production unit will start rolling out the door here at the end of May for field trials. So our machine is going to be portable. So we're going to take wood from majority demolition sites. This is our primary feedstock for our machines, and we're going to remove all the metal from it. And once it's metal free, then you can use it in architectural products like tables and furniture and wall facades and ceiling facades. You can use it interior, exterior, just like you do virgin wood, and you can even use it structurally. We process 2 main types of wood. We process solid timber from 2x4s up to 6x18s, and then we also process glulam as well within those same cross sections. And it's everything from 6-foot long pieces up to 40-foot long beams. And our core scope of work is just getting that metal out. Once the material is metal free, back into the wood supply chain it goes, and you can use it in your projects. And as Jorie mentioned, the quality of the material that we get is much higher quality than what comes out of the forest today. So it creates a lot of beautiful elements. We get rough sawn material, going back 60 to 100 years that we can use in projects. And it's great, to be able to reuse this material and maintain that carbon in the building versus putting it in a landfill for slow release or instant release in an incinerator. So if we hit the next slide, yeah, there we go. So in the design world, how can you guys help, right? How can we change the industry? Because yeah, we've got the technology to make this happen, but we need 2 things to help out and to really drive towards that reclaiming as much of that 37 million tons. The first one is on the demolition process. So as many of you have seen, the preferred demolition process today for demo contractors is to take an excavator and smash the hell out of the building. And the reason why they do that is the only financial incentive they have is to minimize cost. They're trying to make it in small pieces so they can minimize the number of trucks to send it to a landfill. There is no large, purchasing of lumber available today. If you look at the demo sites, you'll see the demo contractors on your commercial industrial projects, they'll separate out concrete, they'll separate the steel because they have reuse opportunities for both those materials. Unfortunately, they don't have any for wood. And so we want to change that. We're changing the economics by bringing down the cost to denail and clean up this material so it can go back into the supply chain. And so what we're asking for the design community is to specify deconstruction. Now, a couple of things for you. If you've ever tried this, sometimes contractors will push back and say it's more expensive. Sometimes it is, sometimes it isn't. It really depends on the building you're bringing down. For example, if you're bringing down a 1950s to 1960s warehouse with open beam ceilings and large spans, typically the cost is the same to deconstruct it as it is to demolish because it's real easy to get to the material. If you're taking down, say, a multi-tenant apartment building where a majority of your wall is 2x4s with sheetrock on both sides, deconstruction is going to be more expensive. The other pushback sometimes you'll get is from general contractors. I'd say, hey, this is going to take longer. It does. We're going to be straight up honest with you. The deconstruction process takes longer than demolition, but you're saving all this material, and sometimes that material has more value than the new stuff going in, which helps on the cost side. But what we found is general contractors will push the demo guys to hurry up and crush a site or a building and clear it, and then it'll sit empty for months and months because a lot of times the general has a milestone to deliver a clean site. So what you need to do is have a realistic conversation with the owner and the demo and the general contractor that says, hey, look, do we really need to clean this building off the site this quickly? let's take our time, let's deconstruct it. It's not going to impact the whole schedule because we're waiting for foundation permits, we're waiting for civil permits. Every demo site we've been on, they're clear and empty after the building comes down, and then there's a long wait. So take advantage of that schedule to deconstruct the buildings and put that in your specs. And make sure you do it up front before you bid out the demo scope. You'll be surprised at how competitive the deconstruction prices are compared to demolition. The next task for you guys is after we reclaim that material, now we've got an inventory of material, how do we reuse it? And so on the flip side, in your specifications, specify reclaimed lumber as a preferred material. The more people that specify it, the more material we cover, the more cost competitive it becomes with virgin. And that is our goal as the technology provider, is to bring down that cost for reclaiming lumber so it competes with virgin. This way you can have a locally sourced material. Imagine you're in the LA metropolitan area and you can get locally sourced reclaimed lumber for your project. That's a huge win on the sustainability front. It's not going to a landfill. There's no train to bring it out of the Pacific Northwest. Your trucking is very minimal depending on what you're going to do with it. And you're reusing a high quality product in your buildings. The other thing to note too is the lumber itself can be regraded, so you can reuse it for structural purposes. And it takes a lot less energy to reclaim than it is to construct. And then the third one is, let's think about long-term. Think about in your designs, how do you take this new structure apart, right? How do you deconstruct it? Nuts, bolts, and nails are great fasteners. Please avoid the glues. Glue is really hard to separate because it actually permeates the wood. It bonds with those fibers and creates a really strong bond like it does in glue lamp. But unfortunately, once you glue wood together, it's either got to be reused as is or it heads to a landfill. It can't be composted. It can't go into a green bin. Those glues are typically petroleum based. They're really strong. They build a great product, but we really need to use a lot less glue in our projects. The more screws, nuts, and bolts you use, we can undo those. Our robots can remove those. That's something that we can completely undo for deconstruction. And so this third item is really that longer term objective, right? Over the next 100 years, when today's buildings start to get disassembled and reused, let's make them easy to take apart so we can reuse all those materials over and over again and not have to pull in virgin materials every time. So if you want to learn more about Urban Machine, hit up the QR code and ping us. This year, we're focused on Northern California. We're going to be going to demolition sites, C&D facilities with our machines starting here in June. We'll be sharing updates and stuff on LinkedIn and our website of those trips. And then in 2024, we're going to be building about a dozen systems and we'll start to expand. Our goal is to put 1 or 2 systems down in LA next year, as well as Portland, Oregon, Seattle, head up to Colorado, about 6 different metropolitan areas for 2024. Working with demolition contractors, working with developers, owner operators to clean up this material and get it back into the supply chain for the projects. So thank you guys very much. And with that, I think we'll turn it over to Q&A.
Amazing. Thanks, Eric. Thanks, Jorie. Yeah, really exciting and looking forward to getting this down in Los Angeles. We have a couple questions in the chat. We'll start with you all. First question is from Meru, which is, how do you consider biogenic carbon for reclaimed wood?
How do you consider which for reclaimed?
Biogenic carbon, which might be a bigger discussion. We might want to take that, have a whole webinar for that, but what are your thoughts?
Yeah, so right now the research that's been done was done by the EPA, and what they really looked at was the operational process for virgin lumber compared to reclaimed lumber. And so they looked at the carbon generated in terms of harvesting virgin lumber, processing virgin lumber, turning it into lumber. And then they compared that to the effort it takes to reclaim lumber, deconstruct it from the buildings, clean the metal out of it. And they looked at the carbon comparison of the two. And that's where that 90% delta comes from, because really virgin lumber is very carbon intensive in the drying process. The kilns and stuff to get to dried lumber is quite energy intensive. And so that's one of the big deltas. And then obviously the logistics footprint, logging in a forest, you're trucking it to a mill to a reman plant to a job site with trains, a lot of diesel fuel involved in that. And that was the other big component of it.
Awesome. So, yeah. If you have a link to that EPA study, I think people would benefit.
Yeah. We can dig that up and share that with you guys. Absolutely. And so that's kind of how we come up with that delta on it. In theory, the carbon stored in the wood in the buildings, the wood's going to dry and it loses moisture content with age, but the carbon content should remain the same. The only time it would actually change is if the wood actually gets degraded, say termites get to it, water damage, you get rot or decomposition in the buildings. But we can't reuse that anyways. Once water gets to it or the bugs get to it, it's back to the compost pile.
Thank you. Okay, next question. We might have to do a little rapid fire with a few questions here. Is from Khalid. How is the lumber industry responding to your idea for deconstruction and reuse? What's that interaction been like?
Yeah, so we were just up at the Mass Timber Conference in Portland, and they love it because the big hole in the lumber green story is the circularity right now. Steel, aluminum, concrete, they have almost closed loops for the most part, energy intensive, but they're not going to the landfill. Wood doesn't have that today. Majority of it heads to landfills and incinerators. And so this really completes the wood story and gives it that circularity.
Okay, next, still sticking with Urban Machine, is how does the regrading process work?
Yeah, so it's the same process they do with virgin. You can do visual grades, you can do mechanical grades. They will come out on a grader, will grade stockpiles of lumber. So if you need regraded salvage lumber, it's just a matter of scheduling a grader.
Awesome. And then I also had a question, kind of taking a step back, a broader question. Marcus, you sort of mentioned how policy had been really key up in the San Francisco area. Can you speak a little more to that and potentially, how do we, there's a nice group here, like how do we get this going in Los Angeles? What do we need to do to that process going?
We were really, so San Francisco was really fortunate to have Eden Brookman, at the Department of the Environment. She's now moved to San Diego. Is really lucky because now she's moved down to be the chief sustainability officer in San Diego. But it was really her brainchild to bring policy forward. The city, Bay Area, similar to LA County, is made up of all these various jurisdictions. So Palo Alto, for instance, has released a deconstruction policy. They put it forth, I think, about a little over a year ago, and they're testing it out. Right, it still has some growing pains, and it's mostly for buildings that are coming down. Right, they haven't yet said, hey, we're going to start to spread that out to say fit outs for interiors. Right, but I think the policy piece is super important. Again, with Eden's, at least what she was envisioning is that you need to kind of develop this system first if you want the policy to succeed, right? You have to kind of set people up for success, teams up for success, and test it out. And so, and that honestly, that's consistent with what we had a research team for Gensler in our Newport Beach office we had a research study called Designing for Disassembly, where they worked with a developer that was doing a lot of build outs. And they found that was kind of a key piece, right? In order to make this incentive possible for people to say, hey, this is going to pay off, you need to have kind of policy from the local jurisdiction.
Thank you. And sort of on that same vein, more on the design side, though, there's a question from Rochelle about suggestions for replacing glue that allow for similar occupant experience.
Yeah, so my anti-glue crusade, right? So a couple of fascinating techniques you got for wood-to-wood connections. There's a couple of products called nail laminated timber, dowel laminated timber, which both use a physical connection instead of glue, whereas cross-laminated timber typically uses glue for its adhesion. And so both of those products are available. There are manufacturers here in North America that make them. We do recommend those using nails and dowels and bolts in any type of wood-to-wood connection.
Sorry, can I clarify that for a sec? Because I think I wasn't talking about cross-laminated timber. I was just talking about when you glue the plywood to the joist to prevent creaking and squeaking and stuff.
Yeah, so in that particular connection, ring shank nails and screws go a long ways. A lot of contractors typically, use the nail gun with glue underneath it on a standard 16 or 12 penny nail. You can typically look at a screw fastener to prevent that squeak as well. But I'd take a look at some other options, because unfortunately, when you glue that sheet good down, it's garbage when it comes out. And there's actually a company up in Oregon that is reclaiming plywood from buildings and turning it into new wood products for buildings. They're creating some mass plywood panels with it. So yeah, if you can avoid glue on that connection, please do. And this is still an area that's early on. I'm sure, previously lots of buildings were done without glue, but as you noted, you do get the occasional squeak in the floor, which some people don't like. But I would try and look at other fastener mechanisms that can be removed.
Okay, thank you.
Thanks, Eric. And I think we're going to quickly run out of time here. But maybe in just the last minute, I have one question for Daniel, and we'll try to follow up. There are a couple other questions in the chat, but I'm just thinking if from what you're saying at Rheaply, is there anywhere you recommend is like the lowest barrier to entry? You mentioned surplus materials a little bit. Is there anything you'd say, oh, check out carpeting, or check out, anything you'd recommend as a kind of a closing first step for folks?
Yeah. The ceilings and floors definitely have some products there that I think are ripe for reusability. Beyond that, I think like following what your local service providers are working on. Marcus mentioned Andrew with Doors Unhinged, providing amazing services for repurposed and reclaimed doors. Anywhere that there's others in your area that are specializing in certain products or certain materials, work with them. Like they are creating that low-hanging fruit for you. And if I can help you find them, I will. If we can help you find them, we will. But I think that's really a great starting point.
Amazing. Well, this is really, this whole space is really inspiring to me, and I'm sure everyone on the call got a lot out of this, loads of information and resources. So thank you to our speakers, Marcus, Daniel, Jorie, and Eric. Really appreciate your time. And as CLF, we'll be following up with the group, for future events. So stay tuned. But yeah, thank you, and hope everyone has a great day.
Excellent. Thank you, Luke.
Thanks all.
Thank you, everyone.
Thank you.